Good evening, ladies and gentlemen. How are we doing tonight? I'll lead back here with a little discussion on quadratic functions. We're going to look at some quadratic functions. We're going to talk about some properties of quadratic functions. We're going to, more importantly, talk about the graph of quadratic functions. What the heck is a quadratic function? A quadratic function is a function given in this form. F of x is equal to ax squared plus bx plus c. What's special about this form? What's special about this form is a, b, and c are the real numbers. Those are arbitrary constants. Real numbers such that a does not equal 0. If a would equal 0, then we'll be talking about a linear function. And this video is about quadratic functions. Quadratic functions and the properties thereof. Quadratic functions, we have two variables. We have the output of the function and the input. The input's going to be the x. The output's going to be the f of x. Quadratic functions. Quadratic function is a polynomial function. Polynomials are smooth and continuous. We'll talk about polynomials more down the road. Here we go. What's the first thing when talking about any function? The first thing you want to talk about when you're analyzing any function is the domain of that function. And the domain of a quadratic function, the domain is all reals. X can be any real number. I can put any x, any real number into that function, and I will output a real number. No restrictions on the domain of quadratic function. What about the output? What about the output? What about the range, what we call the range values? Well, the range values depend. That's something that we're going to talk about is the range. We're going to learn how to find the range of a quadratic function. It's going to change for all quadratic functions. So let's talk about, with respect to that, hey, the graph of a quadratic function. We're going to talk about the graphs of quadratic functions. The graph of quadratic function, the graph of every quadratic function is a parabola. What the heck is a parabola? It's like a U where you take the top and spread out, or it's an upside down U and you take the arms and spread it out. You know what a parabola is? We've looked at parabolas. The graph of a quadratic is a parabola. What about that parabola? Well, here's something about that parabola. If that real number a, that's not 0, if that real number a is less than 0, i.e. a negative number, the parabola is going to open down. Parabola opens down. Look in there, and if it's going to open down, it's going to have a maximum point. We'll talk about that. We're going to be talking about that maximum point there here in a little bit. If a, slow down a little bit, pause the video. For most of you, that's going to be a review anyway. Pause it, and now restart it. If a is greater than 0, if this guy a, if this dude right here a, if that dude right there, which is not 0, if that a is greater than 0, then the parabola is going to open up. It's going to be concave up. If a is less than 0, the graph is going to be concave down. Open down, open up. Concave down, concave up. A is less than 0, bam. A is greater than 0, bam. This is probably a review for most of you. If it is, Happy New Year to you. If it's not, oh well. If it's not, then it's new to you. If it's not, then hey, right here we are. Okay, the vertex, what the heck, what? The vertex is going to be this guy right here, is this maximum point or this minimum point is the vertex. And we know that. We've been talking about this vertex for a long time. What the heck, what? The vertex can be found. This is the rule for the vertex. Negative b over 2a, that's the x coordinate of the vertex. Put that negative b over 2a into the function, and the output, that's the y coordinate of the vertex. So the vertex is always going to be negative b over 2a, f of negative b over 2a. That point right there. Negative b over 2a, f of negative b over 2a. Do I have anything else over here? I don't, but I have something over here. You know what else is nice about a parabola? Parabolas have line symmetry. They have line symmetry. That means you can take this half of the parabola and flip it across that line and it becomes that half. You know what symmetry is? You talk about symmetry in geometry, line symmetry, rotational symmetry. This does not have rotational, it has line symmetry. And we can actually find the line of symmetry. And the line of symmetry is x is equal to negative b over 2a. The x-coordinate of the vertex is the line of symmetry of that parabola. All right, good deal. First slide down. First slide down. Let's go to 100% on that slide. Hey, we all know, pause the video if you need to write any notes down. Okay, here we are, slide number 2. We're going to go to slide 2. Here we go. Uncle Lee here with slide number 2. I'm going to go to tools. I'm going to go the revealer. I like to, whoop, 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 whoop. Let's go to tools. I like the revealer. I want that dude to be on. There we go. Here we go. Okay, if a is less than 0, the graph or the parabola, here we go, it has a maximum point. We talked about that. And what is that maximum point? We know what that maximum point is. That maximum point is always going to be that vertex. Here's what's nice. True or false? If it has a maximum point, that's how I'm going to find the range. That's how I'm going to find all of the possible y values by looking at the y-coordinate of that vertex. And if it opens, if a is less than 0, the graph is open down, so the range is going to be all y's such as y is less than or equal to f of negative b over 2a. So the y-coordinate is going to open down, so I want all the y's. The range is going to be all y's less than or equal to that f of negative b over 2a. Hey, what about, and this is something else if a is less than 0. This is something that we're going to really talk a lot about in calculus and more in pre-calculus. Hey, is it increasing or decreasing? Where's that graph increasing? Where's that graph decreasing? Well, let me tell you, ladies and gentlemen, if a is less than 0, the graph of the parabola, the graph or the parabola has a maximum point. And the range is y is less than, but hey, guess what the graph does? The graph increases. The y values increases, the x values increase. And then it gets to the point that it starts to decrease. So this happens if you have a maximum point. You go up, and then you go down. You go up, you go down. I don't have a graphical representation of that, but I did on the previous slide. Those are all things happen if a is less than 0. We have a maximum point, and the graph increases, then decreasing. Hey, and some of the questions say, hey, what is that parabola? Where does the graph of that parabola increase? Where does the graph of that parabola decrease? You're going to find the vertex. It's all about the vertex, ladies and gentlemen, all about the vertex. Here we go. Hey, if a is greater than 0, the graph or the parabola, the graph, which is the parabola, the parabola has a minimum point. It opens up. Has a minimum point. What do I know? What am I going to use that minimum point? I'm going to use that minimum point to find the range, first and foremost. And what do I know? If it has a minimum point, the range are all the y values greater than or equal to the y-coordinate of that vertex. The range is going to be y greater than or equal to f of negative b over 2a. Oh, I'm going too fast. Pause the video. That's what's nice about the video. It's not real life. It's video. It's called a video. Pause it. Pause it. Now we're back. Hey, what else do I know? If I'm going to be talking about increasing, decreasing, if I'm talking about increasing and decreasing, or increasing and decreasing, or decreasing and increasing, if this has a minimum point, what am I doing? Oh, it looks like I'm going to be decreasing and then increasing. That's what happens around local minimum points. We'll talk more about that in calculus and pre-calculus. So what do I know? Oh, the graph decreases, then it increases. It decreases, then it increases. Let's look at the full slide here. Everything here on this slide. Did we get everything on this slide? Yes, we did. Here we go. Maximum. A is less than 0. I have a max point. Increases, then decreases. A is greater than 0. I have a min point. The range. The graph decreases, then increases. Thank you very much. So I have the revealer. I don't have the revealer. On to the next slide. Here we go. And I want 200% here. What do we got? What do we have right here? Oh, what about... Hey, what about the Y-intercept? Every parabola Every parabola, every quadratic function, yes, has a y-intercept. Why? Because the domain is real numbers. How do you find the y-intercept? You put 0 in for x. You put 0 in for x, you put 0 here. A times 0 squared is 0 plus 0 times b is 0c. The y-intercept is always 0c. Always. Hello, neighbor. The y-intercept is easy. That's easy. I could teach a monkey how to find the y-intercept of a quadratic function. Could you not? Yes, I could. Okay, here we go. What about the x? Ooh, oh. The x and, whoa, 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 whoa. The x-intercept, that's a question mark. The x-intercept. Doesn't matter what color you put it in, the x-intercept. What the heck is the x-intercept? Well, the x-intercept is going to happen. When is the x-intercept going to happen? The x-intercept is going to happen when the function, when the output values of the function equal 0. Where the y's equal 0. Where the y is equal to 0. How can I, ooh. Where this is equal to 0. Where that, oh, is equal to 0. Where that is equal to, hey, why in the world do you think you learn about the quadratic formula? You use the quadratic formula, ladies and gentlemen, to find the x-intercepts of quadratic function. Hello, neighbor, right here. And what I want to talk about more than using this, I'm going to talk about the nature of those x-intercepts. By how am I going to talk about the nature of those x-intercepts? Well, there's the quadratic formula. I didn't even need to put that down because you guys are quadratic formula gurus, if you will. You know the quadratic formula inside backwards. You got the little song, and I'm not singing it. I don't like the song, but go ahead and sing it. I like songs. You like songs? I like songs. So this is the quadratic formula. I used to be a singer. No, I didn't. I'm just kidding. That's the quadratic formula. What I'm going to look at on the quadratic formula, I'm going to look at, oh, you did this before even. I'm going to look at the discriminant of the quadratic formula, and I'm going to use the discriminant to tell me the nature of the zeros of the x-intercepts, if you will, of the quadratic formula. Next slide, please. Next slide. The discriminant, negative b over 2a. I think I even have the revealer here. I do not. Okay, we won't use it. So here's the discriminant, negative b minus 4ac. Let me go back here to my revealer. I don't know why I have to do this each time, but I do. Oh well, there's my quadratic formula. And that's the discriminant. Negative b minus 4ac. Or, pardon me, b squared minus 4ac, that's the discriminant. And I'm going to look at that discriminant. Okay. And then I'm going to say, hey, you know what? If that discriminant is equal to 0, the square root of 0 is 0, then I'm going to have one x-intercept, ladies and gentlemen. Count them. That's going to be 1. And what's that x-intercept going to be? That x-intercept is going to be negative b over 2a comma 0. That's the one x-intercept. If the discriminant is 0. If the discriminant is 0, if this rascal there is 0, I have one x-intercept. What is that x-intercept? This rascal right here. Hey, what about if the discriminant is greater than 0? If b squared minus 4ac, this is going to help us when we graph those quadratics. I can know immediately what the graph is going to look like. Hey, if b squared minus 4ac is greater than 0, then I'm going to have two x-intercepts. If that's greater than 0, I can square root a positive number. And then I'm going to have two x-intercepts. I'm going to have negative b plus the square root of that creature over 2a. And I'm going to have negative b minus the square root of that creature over 2a. But what I want to tell you right now is that if that thing is greater than 0, ladies and gentlemen, I have two x-intercepts. And I'm going to find them. I have an example. I'm going to use the quadratic formula to find those two x-intercepts. Okay, here's an example of one that has two x-intercepts. Hey, what's the third case? I had two cases here so far. If the discriminant was equal to 0, if the discriminant was greater than 0, and here's the third case right here. If the discriminant is less than 0. If the discriminant is less than 0, oh my goodness gracious, if the discriminant is less than 0, that means I'm trying to square root a negative number. And we are doing functions of real numbers. Our outputs can only be real numbers. We are analyzing functions of real numbers, such that the input of the functions we're talking about are real numbers, and the output are real numbers. So I can't even talk about if this is less than 0. I have no x-intercepts. What would it look like? Well, it would be a flying parabola. It would be a parabola that does not cross or touch the x-intercept, the x-axis. It would have 0 x-intercepts. All right, here we go. What else can I tell you? What else can I tell you? I don't know. Let's see here. All right, so let's do an example right there. So what have we talked about so far? Slow your roll a little bit, Levo. Slow your roll. So we're going to have an example, a concrete example here. I want to find the domain. I want to find the range. I want to find the vertex. I want to find the intervals where that graph is increasing. I want to find an interval where the graph of this function is decreasing. I want to find the y-intercept of that function. I want to find the x-intercepts of that function, and I'm going to come up with a graph of it. Okay? Hey, what's the easiest thing to do? I know the easiest thing to do is the domain. And I want to find, what do I need before I find the range? Of everything here, the domain is going to be easy. The domain is all reals. But if I want to find the vertex, if I want to find the range, if I want to find the intervals of increasing, and the intervals where this thing is decreasing, what do I need to find? I need to find the vertex. It's all about the vertex, ladies and gentlemen. It's all about the vertex. So let's find the vertex. Here we go. Here's the function right here. Whoa, next slide. Whoa. Here's the function. First thing I do is pick out the A, pick out the B, and pick out the C. The A is 2. The B is that real number -3. C is that real number 1. And I find the vertex. The vertex, the x-coordinate of the vertex is -b over 2a. Negative b is going to be 3. Negative 3 is 3. 2 times 2 is 4. So the x-coordinate of the vertex is 3/4. I'm just finding the vertex. Finding the vertex. 3/4. Now I want to find f of 3/4. So I'm going to put 3/4 into the function. Put 3/4 into the function. What outputs is the y-coordinate of the vertex. Thank you very much. So I'm going to put 3/4 in. Hey, I can do this arithmetic. I can do it. I can do it. 5th graders can do this. Well, I don't know. Maybe 6th graders, some could. All we're doing is dealing with fractions. So we're going to put 3/4 in here. 2 times 3/4 squared. 3/4 is the x-coordinate. 3/4 squared. 3/4 times 3/4 is 9/16. Hello, neighbor. Okay, and then 3 times 3/4 plus 1. So let's do the math here. So 9/16. 2 times 9/16 is 18/16. 3 times 3/4 is 9/4, but I'm subtracting that plus 1. And I want to add all those fractions together, so I'm going to do least common denominator of 16. Hello, neighbor. Right there it is, 18/16. 9/4, multiply that by 1 in the form of 4 over 4. 9 times 4 is 36. 4 times 16. That 1 is 16 over 16. Check this out right there. Slow it down if you want to. Pause the video. That's what's nice about the videos. Okay. Hey, look at this. Negative 16, 36/16 plus 16/16 is negative 20/16 plus 18/16, negative 2/16, negative 1/8. Hey, that's the vertex right there, ladies and gentlemen, the vertex. Then I write it down. The vertex is going to be, what is the vertex going to be? 3/4, comma, negative 1/8. That's going to tell us so much. That's the vertex, input, output. So much. Here we go. Since I know that. Okay, here we go. The domain is all reals. Hey, in A, true or false, A is positive. So it has a minimum point. So my range, if I look back at my notes, my range is going to be all y's greater than or equal to negative 1/8. That's the y-coordinate of the vertex. It opens up, it has a minimum. So now I got the range. I found this vertex, 3/4, comma, negative 1/8. The range, all the y is greater than that. Hey, and if it opens up, it decreases, then increases. Oh, and then this is an error right here. Yeah, this is an error. If it's increasing from 3/4 on. Better change that, Lebo. Oh, yeah. Let's change that. Because it starts out, if it opens up as it does, it starts out decreasing. Then it's increasing. And the intervals of increasing, decreasing, we want to put in x values. So let's put those in x values. So this thing is decreasing from negative infinity to 3/4 now in that interval. And it's increasing from 3/4 to positive infinity. So we're going to change this over here too. So it starts off decreasing because it has minimum. Because A is positive, it opens up. So it decreases, then increases. It decreases to the x-coordinate of the vertex. And then it starts to increase. So let's change this over here. Let's fix this rascal over here. Let's give me a little eraser there. And let's see here. So this is, I had decreasing or increasing first, and it's increasing from what? From x equals 3/4. This is just another way to write the interval notation. I will accept any form if you want to go intervals of increasing via interval notation or just writing it out. It's increasing from x equals 3/4 to positive infinity. And it's decreasing from a negative infinity to x equals 3/4. Alright, here, let's go. And now what else do we need to find? Oh, the y-intercept. The y-intercept is so easy to find. Just put 0 in for x, but out pops a 1. If you put 0 in for x, you put 0 in for x right there. 2 times 0 is 0, minus 3 times 0 is 0, plus 1. That's where you get the y-intercept, 0, 1. And now I have to find this x-intercept. How do I find this x-intercept? How did I get those points? I'm not even going to write. How did I get the 1/2, 0, 1, 0? How did I do that? How did I find the x-intercepts? How did I find that? Yes! You're right. You're right. Yes, you are, Billy. You use the quadratic formula. Let's use it. Let's go down here and use the quadratic formula. I think we're right here with the quadratic formula. Right here it is. Yes, there it is. I'm going to zoom in or out. I never did understand the zooming in or out. Here we go. F of x, I want to find the a is 2, the b is -3, the c is 1. I'm going to look at my discriminant. b squared minus 4ac, b squared, -3 squared, 9, minus 4 times a, which is 2, times c, which is 1. 4 times 2 is 8. 9 minus 8 is 1. Oh, that's nice. 1 is greater than 0, so now I know there are 2 x-intercepts, ladies and gentlemen, because the discriminant is greater than 0. And this makes it really nice too, because if my discriminant, since my discriminant is 1, I mean I got lucky on that. When the discriminant is 1, the square root of 1 is 1, so it's going to be easy to find the x-intercept. The x-intercept, b was -3, is going to be 3 plus the square root of 1 over 4, comma 3 minus square root of 1 over 4. Square root of 1 is 1, hello. 4 over 4 is 1. 3 minus square root of 1 is 1. 3 minus 1 is 2 over 4 is 1/2. So here's my x-intercepts. Oh yeah. 1/2 comma 0, 1 comma 0. Those are my 2 x-intercepts. I'm back here right here. That's where those guys came from. You're going too fast. Just pause the video. That's what's nice about these videos. You can pause them. How many times have you said that? How many times? How many times? Let's look at the graph. You want to? Let's look at the graph. And bring this rascal to an end. And there's my graph. This tells the whole picture. Here's the vertex, 3/4, -1a. It decreases to x equals 3/4. You do intervals of increasing, decreasing with respect to the x values. It decreases up to x equals 3/4, and then it starts to increase. My vertex is right here. My y value is my output, my range. Y is greater than or equal to -1/8. I have a y-intercept, 0, 1. I have an x-intercept, 1/2 comma 0, and another x-intercept, 1 comma 0. Let's look at the whole thing. Whole slide. Ladies and gentlemen, that's about it with respect to quadratic functions. You've got the vertex form that we're not going to use a whole lot. If you can wrap your head around everything that we've talked about with this on this video, you're going to be okay with quadratic functions. But you absolutely, definitely need to get your head wrapped around the quadratic functions. Uncle Lee, signing out. Catch you on the flip side.